I welcome the organizers and participants of the CMIS-2020 conference. A report on the subject is brought to your attention. Optical electronic system of automatic detection and precise tracking of aerial objects in real time. The development of high-tech weapons and military equipment is increasingly demanding the detection, tracking and delivery of measurement information on target movement parameters. Currently there are both high-precision stationary measuring complexes and fully automated optical electronic and television measuring complexes. Analytical review of optical electronic systems can conclude that there are too many systems for object tracking and detection, but they do not have the hardware for trajectory measurements of object motion in real time and mode. Therefore, it is currently urgent to develop a new automated optical electronic measuring system and special algorithms for its operation, aimed at working in automatic mode and in real time. The purpose of the work is to develop digital video processing technology in the visible and infrared frequency bands for automatic detection and high-precision real-time tracking of aerial objects that will solve the following tasks: improving image quality, reducing visible noise on the image, improving image contrast, improving clarity, adaptation of the camera to poor working conditions, low light, fog and other atmospheric influences, search for a moving object based on a priori information about its type, shape, speed and nature of movement. Automatic identification of the object type by comparison with the standard in shape, color, surface texture, speed of movement. Formation of special points of the accompanying object, the most informative or vulnerable points, the center of mass, etc. Accurate support of the object on the selected points on its surface. Predicting the trajectories of objects accompanied, recapture of the object in case of failure of its accompaniment. On slide 4 shows the composition optoelectronic system for detection and tracking of moving targets in the air. On slide 5, shows the mathematical models and methods have been developed and implemented. On slide 6, shows the methods algorithmic support of the digital image processing module. On slide 7, shows the software module digital image processing for PC. On slide 8, shows the digital imaging module software for boards Links Zinc Ultrascale Plus MPSoC ZCU104. Testing the algorithm of tracking the aerial objects and assessing its performance was carried out in the laboratory on static and dynamic scenes using a simulated moving air object placed on the background, which allows to simulate different conditions of visibility, contrast, of the accompanying object. As a result of testing, it is established that when executing the FPGA algorithm, the time spent on frame processing does not depend on the object configuration, frame filling and background characteristics. Table 1 shows the results of a study of the performance of the developed algorithm and comparing the performance of the calculations for the implementation of Harris function on a PC and FPGA. Conclusions 1. The prototype of the OES for the detection and maintenance of moving targets in the air environment is developed. The development of a new automated OES and special algorithms for its operation, aimed at working in automatic mode and in real time. So the detection and tracking of characteristic points on the target performed on FPGA. 2. Digital video processing technology in the visible and infrared frequency bands has been developed for the automatic detection and precision tracking of aerial objects in real time. The main components of the flowchart of the algorithms for identifying, capturing and tracking targets are identified. Software implementation of all digital video processing features on FPGA is not possible, so at this time a compromise solution was proposed using a PC and ZCU104. 3. was a study of the performance of the algorithm developed and a comparison of the performance of the calculations to implement the Harris function on a personal computer and FPGA.